In this video, I'll be introducing you to the topic of limits. And these are limits in the first thing. This is one of the first things you learn in Calculus 1. So congrats, you're in college math now. You're in the big leagues. Okay, so what is a limit? So let's draw a random graph. So this random graph, actually, I'll draw the negative and the x. So this graph has, let's maybe say it's a wave, right? And it cuts off. We don't see the rest of the graph. Now, what does the limit describe? Well, let's say that there were 2 points. You pick 2 random points on this graph that are on the opposite sides of whatever limit you're trying to solve. Let's say you're trying to solve a limit at x equals 0. So the symbol for that would be the limit as x approaches 0. And this stands for a limit as x approaches 0. Well, what does this mean on this graph f of x? Well, as these 2 green dots get arbitrarily close, so it doesn't matter, just so close, super close to x equals 0, so you just drag these green dots, get closer and closer and closer until both of these green dots are quite literally right next to x of 0. So it could be at 0.0000001 or negative 0.000000001. Basically, what a limit is, measures the value of these 2 green points, or the y value of these 2 green points, as they get arbitrarily close to x equals 0. So what a limit kind of does is tell you the behavior of this function, so the behavior of the function as it approaches the point that you are trying to approach. So this blue point that we're trying to approach at x equals 0 along the function is just at the origin. So we can say that this limit as x approaches 0 is just 0. Now you might be wondering, oh, well, isn't the limit literally just the same as the values of the function? Well, no. Because sometimes you're going to get holes in your function. So what is a hole inside of your function? Well, a hole inside of your function is some point where there is no value. And let's say this is x equals 1. So what does this hole do? Well, this hole, if you were to plug in 1 for your function, then you wouldn't get a value. You would get undefined. You would literally get nothing because there is no value at that point. Now, when you're solving for limits, you'll understand how these formulas work. But for now, just understand the concept of a hole. You don't need to know what the formulas or the functions look like. So this is where limits come in. Well, where limits come in is if you take the limit as x approaches 1. So as 2 points, so 2 points in yellow now, infinitely get close to this hole, well, you would get some value. You would get some y value, right? Although the limit is infinitely close, it isn't at that point. So this limit of your function sort of tells you some behavior of the function as it approaches this point. So what's the y value at this point, or the function value? So let's say the y value is 2 here. So as a limit x approaches 1, as a limit of x approaches 1 for your function, this red line right here, basically 2 points on both sides get infinitely close on both sides of this hole, and then it tells you the y values of both of these infinitely close points, and that's 2. But if you were to just plug in 1 directly, you would get an undefined value. So the limit can tell you the value of function even though, or at least the behavior of the function as it approaches that value, without actually plugging the 1 into the function. Rather, you take the limit. So what are some ways you can solve for limits? Well, some ways you can solve for limits is, the first one that you learn is quite literally just plugging in some value. So let's say you had a function, and this function was equal to maybe 3x squared. Okay, and if you want me to draw out this function, it literally just looks like a parabola, but it's stretched out So this is your function 3x squared. And let's take the limit as x approaches, let's say, 2 of your function f of x, or 3x squared. So what does this equal? Well, you could actually just plug in 2. So you can just plug in 2 here. So if you plug in 3 times x to the power of 2, so if you plug in 2 here, you get 3 times, well, 2 to the power of 2 is 4, so you get 3 times 4, which is equal to 12. So your value for this limit is just 12. And this is the first thing you should try for all limits when you're solving for them. Literally just directly plug in the number. You can easily do that for a lot of things. Now, what if you had a function that was a little more complicated, like f of x? So your function f of x is equal to x minus 3 x plus 2 over x minus 3. What would your limit be as x approached 3? And now keep in mind, when you're doing your work for this, you must keep the limit symbol throughout the entire problem. So what do I mean by this? Well, when I cancel these out, right, algebraically, you can cancel out the 2 terms on the tops and bottoms of a fraction. Your limit symbol must stay. You can't just omit the limit symbol. So if you canceled this out and then the next step you wrote down x plus 2, well, you're going to get, some calculus teachers are very strict and they're going to take away points from your work. So you must keep the limit symbol within the problem, or at least next to your function. So now that you canceled out x minus 3 in the denominator, well, now you can plug in 3. But what would happen if you plugged in 3 before? What would happen if you plug in 3 here? Well, if you plug in 3 at the top, you would get 0, right? Because 3 minus 3 is 0. And x plus 2, well, since this term is 0, 0 times anything is 0. And 3 minus 3 is also 0. Well, you can't equal 0 over 0. That means that this function is undefined. So you can't solve for the limit as x approaches 3 by just plugging in. But when you cancel out x minus 3 here, well, now you can plug in 3 directly. And what happens when you plug in 3 directly? You get 3 plus 2. Now, this is when you can take away your limit symbol. Once you plug in the x value, once you plug in the number that you're approaching in your limit, then you can remove the limit symbol. It is not necessary to put the limit symbol here after plugging in for x or 3. It is unnecessary. And once you just do this, you get 3 plus 2, which is equal to 5. Now, keep in mind, most of the time when you're solving limits, especially these two-sided limits, this is what it's called, you will have to algebraically manipulate. It's, I would be very surprised if your math teacher just allowed you to plug in the numbers, because you're basically just taking an introduction algebra class at that point. But speaking of two-sided limit, notice how I use that term. Well, when you're just solving for regular limits, so when you see the limit of x approaching some number like 3.5 or some integer 3.5 or 2 or I don't know 4, something 4.21 or something like that, doesn't matter. That's called a two-sided limit. And a two-sided limit is what I stated before. Let's say you get this squiggly line and you're trying to approach x equals 1 here. So at x equals 1, let's draw a dot on the function. You have to draw 2 dots on opposite sides, either sides, and then have them infinitesimally approach closely or arbitrarily approach your green dot here. And whatever the values of your blue dots are along the function is what your limit is equal to. Now, this right here is an important key concept. You have to approach on both sides for a limit. And the reason why this is important is because what if you had a function that looks like this? Well, this function isn't straight line, isn't a straight line. It's discontinuous, as the term is. So let's say you had a limit that try to approach this point x equals -1. Well, first thing we do when you solve a limit, the concept of the limit basically draws 2 points on either side of your function and drags them infinitesimally close to your point of x. Now, look what happens. If you get this blue point infinitesimally close, well, the y value here is, let's say it's 3. Well, the y value here is 3 and the y value here is 1. The limits on both sides will be different. So the limit that's approaching from the left is 3. That's the y value of your function. And the limit that's approaching from the right, going to the left, is 1. So this limit here for this function, as x approaches -1, does not exist, DNE. And you're going to see a lot of does not exists in Calculus 1, because some things just straight up don't exist. This is an important key concept to know. Now, just to give you a quick rundown of what one-sided limits are and what I mean by this definition, I'll have a link down in the description for a more in-depth video, but since this is an introduction to limits, I might as well tell you what a one-sided limit is with a very quick explanation. So a one-sided limit basically is the same as a regular limit. So as x, let's use the example of this problem, as x approaches -1 on the negative side, so we'll put negative here, and the negative side is to the left. So the negative axis is to the left. Therefore, the dot here is what we're approaching with a one-sided limit of. So the dot on the left, the blue dot on the left, is our one-sided limit dot that's approaching infinitely close. Well, our one-sided limit just describes behavior as you approach on one side. The regular limit describes the behavior as you approach on both sides. So in this case, your two-sided limit does not exist because the values are different. Your left dot approaches -1, x equals -1, and you get a value of 3. Your right dot approaches x equals -1, and you get a value of 1, y value of 1. But basically what I said here is as your x approaches -1 from the negative side or the left side, you get a value of 3, correct? This is your value for a one-sided limit. And if you take the limit from the positive side, so plus here, of your function, this function here, then you should get 1 in this case. Because as you approach from the right infinitesimally close to -1, you get a value or a y value of 1. This is a quick rundown of what a one-sided limit is. It's basically just a two-sided limit, but you only care about the direction in one direction. So now that you made it to the end of the video, give yourself a pat on your back. You just learned what a lot of people don't know: limits. So this is your, especially if you're an engineer, this is going to be important to know because you'll be absolutely suffering. But as always, if you have any questions, put it down in the comment section. If you found this video helpful, consider subscribing and liking the video. Thanks for watching.